Okay, here we go, starting on page 2, number 7. Find the area under the standard normal curve to the right of z equals 1. So again, start off by drawing your bell curve. What does this look like to help you figure out what our lower and upper bounds are? So we know 0 is in the middle, z equals 1, that's somewhere to the right, okay? But now then we want to find the area to the right of this number. So that means we're shading to the right. So now thinking about, we know we're going to do our normal CDF because again, we are finding the area. Okay, so our lower bound, that's our smallest number, is 1. And so this time it means our upper bound, since we keep on going to the right, remember that is positive 10,000. And then using our calculators, going to our second vars, and then normal CDF, lower bound, upper bound area would get us, rounding to 4 decimal places always, 0.1587. Area is 0.1587. And again, on area, I should have said this on the last 2 questions, always round to 4 decimal places. So this is answer choice C. Number 8, still finding the area. Find the area under the standard normal curve between z equals 0 and z equals 3. So again, let's start off with drawing our bell curve. No, there's 0. Oh, okay. Z equals 0 and z equals 3. 1, 2. So about right there. And we want between. And we are still finding that keyword is area. So using our calculators, going to our normal CDF. Our lower bound is 0, and our upper bound is 3. So then, putting that in our calculator, we would get, rounding to 4 decimal places, that this is 0.4987. So it looks like that is answer choice C as well. Okay, number 9. Determine whether the graph could represent a variable with a normal distribution. Explain your reasoning. So for number 9, we have a graph that is drawn for us. So thinking about a normal standard curve, well, we just drew it 4 times, okay, right before. Remember our normal standard curve. Looks like that. And we usually don't draw it, but we could draw, like if this was our x-axis, our y-axis going up, that y-axis would be right there at 0 going up, okay? So this is our standard normal curve. I'm looking ahead. At C it says the graph fulfills the properties of the normal distribution. Well, our normal distribution is my orange bell curve up at the top. Doesn't look the same, okay? So no, the graph crosses the x-axis. Looking at this picture, it's very, very close, but it doesn't have where it actually crosses it. So we're going to cross that one out because this is our x-axis down here. Okay, the graph is skewed right. Okay, to be skewed right, that means it has a tail on the right-hand side. Well, right hand, looky there. There's our tail on the right. So that means we are skewed right. Okay, then we know it again, it is not a normal distribution because it does not look like our standard normal bell curve where it does continue over and symmetric on the other side. And no, the graph is not, or is skewed left. That's not right, or that is not correct. Sorry, that is not correct, because again, to be skewed left, it has to have a tail on the left-hand side, and this one only has a tail on the right-hand side. Okay, number 10. Number 10 is where we start getting a little more lengthy. And this is our first one to use an actual formula with. Okay, number 10. The SAT is an exam used by colleges and universities to evaluate undergraduate applicants. The test scores are normally distributed. In a recent year, the mean test score was 1,481 and the standard deviation was 292. The test scores of 4 students selected at random are 1930, 1340, 2150, and 1450. Okay, so part A, find the z-scores that correspond to each value. So our formula to find a z-score, and this should be provided for you, but it's really good to know, is z equals x minus mu divided by sigma. Just in case. Okay, z equals x minus mu divided by sigma. So what do those letters represent? Well, remember, mean is our mu, and standard deviation is our sigma. And then these 4 numbers for the test scores, those are our different x values. So we got to plug that in 4 different times. Okay, so I'm going to start off with 1930. So we have x minus mu divided by sigma equals 1930 minus mu is 1481 divided by our standard deviation is 292. Okay, we're going to put that in our calculator here in just a second. I'm going to go ahead and I'm going to write out each of the rest, just the formulas, what we would get when we plug in x minus mu over sigma equals 1340 minus 1481 divided by 292. All I have to change on these 4 formulas is just that x value at the beginning. X minus mu divided by sigma. 2150 minus 1481 divided by 292. Then the last one, where we have x minus mu divided by the standard deviation, we have 1450 minus 1481 over 292. So putting all this in your calculator, each one individually, of course, 1930 minus 1481, hitting enter, and then dividing by 292. Be very careful because we got to follow the order of operations on these. Okay, so if you do put this in your calculator all together in one swoop, okay, not having to press enter more than once, make sure you put what's up at the top in parentheses, then divide it by the 292, or you can do it in 2 steps, the subtraction first and then divide by what's at the bottom. So whenever we work out that first one with the 1930, we would get that our z-score is 1.54. Remember, z-scores are rounded to 2 decimal places. Okay, the next one, when we plug in 1340, we would get negative 0.48. Then when we plug in 2150, 2.29. And then that last one, when we plug in 1450, we get a negative 0.11. Okay, so these are the first answers that part A is asking. Find the z-scores that correspond. Z-score, 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 z-score. Be sure you box those in your final answers for part A, the z-scores for each of these. Okay, now then part B though. It's asking us to determine whether any of the values are unusual. Okay, so remember we can go back to thinking about unusual z-scores. And remember, unusual z-scores on our number line, we of course have 0, oops, sorry, this is +1, +2, -1, -2. Those unusual z-scores is anything from -2 below it and +2 above it. Okay, those are unusual z-scores. So looking at these z-scores that we have, 1.54. Well, that's 1.54. That's not 2 or higher. Okay, that's usual. -0.48. That'd be somewhere between 0 and -1. Not unusual. 2.29. Ooh, there we go. That'd be about right here. So here we have an unusual z-score. And then that last one, -0.11, again, that is somewhere between 0 and -1, so that is not unusual. So the only value that is unusual is our 2150. So it's actually looking for the unusual, part B. The 2150 is unusual. Okay, it's actually asking for what test value is unusual. Okay, that is page 2.